In this video, we have a look at how to use the unit circle to determine trigonometric values. Now, probably up till now, you've used the right-angled triangle to determine trigonometric ratios. Let's have a look at one right now with the sine of 30 degrees. We've drawn our right-angled triangle, and we know the trig ratio for sine is opposite over hypotenuse. Now, in this case, looking at the unit circle, that vertical height, which is opposite the angle, comes to approximately 0.5. The hypotenuse is the radius of our circle, and the unit circle has a radius of 1, hence the name unit circle. So the sine of 30 degrees is 0.5 over 1, or just 0.5. Now that 0.5 happens to match the height on the vertical axis, which is level to where the angle meets the circle. So we can use that to determine the sine of an angle. Likewise, if we want to determine the cosine of 30 degrees, we know that cosine is adjacent over hypotenuse, and the adjacent side of the triangle in this case matches the length along the horizontal axis, equivalent to where the angle cuts the circle, and that comes to approximately 0.87 for 30 degrees. We can then use that same idea to extend to obtuse angles, which is where we have trouble with the right-angled triangle. So the sine of 120 can be determined by finding where the angle cuts a circle and then going across level on the vertical axis, and that comes to approximately 0.87. Likewise, cosine for 120 can be determined by finding where the angle cuts a circle and going down to the horizontal axis, but in this case that comes to negative 0.5. Let's have a look at another example. Here we've got an angle of 315 degrees, which we say is in the fourth quadrant. We say that because we measure angles from the positive horizontal axis, and we can see here that we've moved around to the fourth quarter, moving in an anti-clockwise direction. So we call that the fourth quadrant. Let's have a look at how we determine sine of 315 degrees. We find where the angle cuts a circle, and then we draw a line across to the vertical axis. In this case, we can see that the sine of 315 degrees is approximately negative 0.71. Likewise, we do the same for cosine, but we draw back to the horizontal axis. In this case, we can see that cosine of 315 degrees is approximately positive 0.71. So how do we measure tangent on the unit circle? So to find the tangent of an angle on the unit circle, we draw a tangent line such that it's tangent to the circle at the positive horizontal axis. We then extend our angle such that it meets the tangent line, and then find how high that is, and we can do that by looking at the vertical axis. In this case, measuring the value on the axis gives us approximately 1, but of course we do know that tangent of 45 degrees is exactly 1, because in a right-angled triangle the side opposite 45 degrees will be exactly the same as the side adjacent to 45 degrees, because it forms an isosceles triangle where we have two equal sides. Let's have a look now at the tangent of 120 degrees. Now you can see that the angle of 120 degrees will not match the tangent. In other words, it won't intersect it by extending it to the left. So we extend it to the right, and then we find where it meets the tangent line, and then again measure the height. And in this case it will be a positive value. So tangent at 120 degrees is approximately 0.58. Let's have a look at angles as we move around the unit circle. Let's first of all consider sine. Now we know that we measure sine on the vertical axis. So angles in the first quadrant will meet the vertical axis at a positive value. And likewise, angles in the second quadrant will also meet the vertical axis at a positive value. So we can say that the sine of angles in the first and second quadrant will be positive. Let's have a look now at what occurs when we look at angles in the fourth quadrant. We can see that they'll meet the vertical axis in negative values, and likewise the same for angles in the third quadrant. So we can say that the sine of angles in the third and fourth quadrants will be negative. So they're angles that are between 180 degrees and 360 degrees. Let's have a look at angles now compared to the horizontal axis. So if we measure angles in the first quadrant, we know that they'll be corresponding to positive values on the horizontal axis, but also angles in the fourth quadrant will correspond with positive values on the horizontal axis. So cosine of angles will be positive when they're measured in the first and fourth quadrants. Likewise, angles in the second and third quadrant will be negative for cosine because they match negative values in the horizontal axis. When looking at tangent, we measure tangent on the tangent line and also how high that is on the tangent line. So angles in the first quadrant and also the third quadrant will be positive for tan. Also, angles in the second quadrant and the fourth quadrant will be measured against the negative vertical axis. So tangent of angles in the second and fourth quadrant will be negative. Summarising that, we know that in the first quadrant, all trigonometric ratios, sine, cosine and tan, are all positive. In the second quadrant, only sine is positive. In the third quadrant, tangent is positive. And in the last or fourth quadrant, cosine is positive. Unit circles are particularly helpful to solve trig equations, so knowing when the trig values are positive or negative is extremely helpful in this regard.